I was just sitting here drinking some coffee, making sure everything was ready for today's Zooms, and I'm having a hard time because, man, the sun is so bright. It keeps shining in my eyes. I'm gonna have to go pull my blinds. You know what? It got me thinking. We're talking about the sun and moon and science this week, right? And besides being bright, what else does the sun really do? Because right now it's cold outside, so it's not like it's making things warm, or is it? I have another question too. How come right now, first thing early in this morning, the sun is in my eyes, but by lunchtime, I can put the blinds up and see perfectly fine? It's like the sun moves. But does it? Where does it even come from? You know what? This calls for a little bit of investigation. So I'm going to go grab my investigation coat, kind of like my detective coat, and head outside and look for some clues and answers. You should come with me.
Hey boys and girls, so as you can see, I got my detective coat on, got some tools in my pocket, and the sun is still super bright in my eyes. But what's really important to note, the first thing I notice is that the sun is over this way, right behind me to my right. So I guess to figure out where it's going, I'm first going to face it. Woo, brightness. And now I'm going to pull out my compass and see which way the sun, which direction the sun is actually in. So let me do that really quick. Oh, that's interesting. Here, let me show you what I see. If I move my body to face the direction of the sun, look guys, the sun is in the east. Check that out. Watch again. All right, if I face my house, I'm facing north, and as I turn my body to face the sun, look at that. So we now know that the sun rises or comes from the east. As I'm looking here in my yard, it snowed this past weekend, right? And as I'm looking in my yard, I noticed that some of the snow is still here, but some of it is not. Look, check it out. So, look here. This is the snow I was talking about. I still have snow up against my house. So, does the sun really provide heat during the day? Well, what else I notice is that if I take a couple of steps back, the sun is not reaching that part of my yard, which means obviously it does, because if it didn't, the rest of my yard would still be covered in snow too. Can you find any places around your house that the sun probably doesn't reach as well as others? Maybe places that you still have snow or ice. All right, so the last thing I'm going to do to test this theory about the sun and it heating the ground is I'm going to take a couple temperature measurements. And I borrowed a meat thermometer from my husband. Shh, don't tell him. I'm going to stick it in the ground and see what temperature the ground is in the sun and what temperature the ground is in the shade. And then I'm going to come out here later in the middle of the day and do the same. Alright, so right now, first thing in the morning, as the sun is rising in the east, the ground's about 34 degrees in the sun. Now let's go check the shade. Alright, here I am in the shade with my snow and ice, and you can see that in the shade, first thing this morning as the sun is rising in the east, that the ground is 32 degrees, which means it's 2 degrees colder than what it is in the sunlight. We'll come back again at lunch and see if the sun's heated the ground any. Okay, so fast forward a little bit. It's now lunchtime, roughly 12:30, 1 o'clock. Ooh, you can hear the wind. It's still pretty chilly out, but look at the sun. It's now moved to the middle of the sky. It's directly behind me back there, right? So look, it moved from the east over here, westward to the center of the sky. So we can definitely confirm that it moves from east to west. We can confirm that it rises in the east. We'll have to come back later and check to make sure that it's going to set in the west to my left over here. Now that we've checked that out, let's check our temperature on the ground to see if it's been doing its job to heat the ground. Let's check in the sun first, and then we'll head over to the shade and see what the temperature says there as well. So, check it out, guys. The ground is 37 degrees now. That means that it has risen a good 3 or 4 degrees since this morning. Oh, it dropped a little bit there. Let's go check out and see what the shade says. All right, here we are in the shade, and look at that. The ground is still 32 degrees over here in the shade. That's the part that the sun hasn't even touched yet. So I think it's pretty clear and true to say that the ground does get heated by the sun. It is working really hard to warm things up, but the season of winter makes the air around us a little cold and chillier than it would in the summertime. All right, we'll come back out here later in the evening as the sun is setting, just to make sure it doesn't pull any tricks. All right, fast forward a little more, and here I am back outside. It's kind of close to 5 o'clock, and as you can see, I'm gonna have to walk forward a little bit and tilt myself this way. There's the sun. He has moved from rising in the east across to the middle of the sky, and now he's working on setting in the west back there behind the carport. So, in fact, the sun does rise in the east and set in the west, moving across the sky. It's at its highest point during the middle of the day, which we saw at lunchtime today. So now let's look at the second part of our investigation. All right, let's check the ground temperature. Well, guys, look at that. Sure enough, as the day has passed, the sun has worked really hard to heat up, hey Duke, to heat up the ground, and it's reading at 41 degrees. Remember, this morning in the sun, the ground only read or measured 34 degrees Fahrenheit. Well, look at that. Still a steady 32 degrees Fahrenheit. So I guess it is true that the sun helps to warm the air around us, as well as the ground and any water.
And I just thought I'd take a quick second before leaving you and kind of going over all the things that we discovered as we investigated the sun today. You know, first thing this morning, the sun was in my eyes, and now that it's starting to set, no trouble. Probably because it's moved past my window, right? So let's take a quick look at some of the notes I took throughout the day and kind of recap what we've learned. We've learned that, well, the sun rises in the east and it moves through the sky during the day to set in the west. Okay? We've also learned that the sun does do its job by warming the air and ground and water around us. And we learned that because we took some measurements. So let's just look at those measurements we took. Let's see. First thing this morning, in the sunlight, the ground measured 34 degrees. Right? And then at noon, at lunchtime, it measured 36. And then this afternoon, when I went out around 4:30, 5 o'clock, it measured 41 degrees. Look at that. So throughout the day, as the sun moved in the sky, the ground got warmer and warmer, getting its warmest toward the end of the day because it's been out the longest, right? Now let's look at what the sun did to the ground in the shade. Let's see, this morning it was 32, and then we went back to the shade again, and it was 32 again. And then this evening, it was still 32 degrees. So, obviously, the sun's not reaching that ground that's in the shade, but that just kind of makes what we thought even more true, because we thought that the sun's rays and heat are what heated the ground, and since it's not reaching what's in the shade, there's nothing that it can heat there, right? So, what you're going to take away with today's investigation is that the sun rises in the east, moves through the sky, and sets in the west. And then throughout the day, it does its job of heating the ground that it touches. Thanks for joining me, and I hope to do some more investigating with you guys later on. Bye.